All right, let's take a look at Chapter 0, Getting Started. In Chapter 0, we cover where the data come from matters, always look at the data, variation is everywhere, and what lies ahead. Getting started. Does SoundScan know what's hot in popular music? Is hormone therapy appropriate after menopause? What are the extent, cause, and possible solutions to global climate change? Statistics is the science of learning from data. Data are numbers, but congratulations, your baby weighs 8.5. 8.5 what? Kilograms? That's a big baby. Data are numbers with a context. Likewise, we will use our human judgment to guide our use of statistical tools such as graphs and calculations. Where the data come from matters. Observational studies versus experiments. Early hormone replacement studies are observational. Challenges are lurking variables such as education and affluence of patients. Later, definitive studies are experiments, decided no reduction in heart attack risk due to therapy. Just one example of complex relationship between variables being oversimplified. Always look at the data. Example graph. A few carefully chosen graphs are often more instructive than great piles of numbers. Always do experiments? You can't. It isn't always necessary. Well-designed observational studies, such as sample surveys, can yield high-quality information. Well-designed doesn't equal a large number of respondents, necessarily. Example, Ann Lander's reader survey. Variation is everywhere. Gas prices from June 1990 to August 2013. Because variation is everywhere, conclusions are uncertain. Example, efficiency of HPV vaccine was 98%. 95% confidence interval, 86% to 100%. Truth? It's in there, or it's not. Variability is inescapable. What lies ahead? The purpose is to give a working knowledge of the ideas and tools of practical statistics. The three main areas are data analysis, chapters 1 through 6, data production, chapters 8 and 9, statistical inference, chapters 13 through 18, and 20 through 27. Doing statistics is more than manipulating numbers. You must state a problem in its real-world context, plan your specific statistical work in detail, solve the problem by making the necessary graphs and calculations, and conclude by explaining what your findings say about the real-world setting.